Hey, welcome back to Mr. B's math class. Today we're looking at 1.2, misrepresenting data. So we have three student outcomes today. One, I can explain how the size of intervals on a graph could be misleading. Two, I can explain how the visual representation of a graph could misrepresent data. And three, I can explain how the size of bars on a graph could be misleading. So let's take a look here. Now I want to mention, as you're taking notes here, you don't need to take notes on these pictures. I don't expect you to redraw these graphs. Just pay attention and write down the key information that you find in the lesson. Okay, it's a little bit different than the other ones. So if we're looking here at this graph, we can see that they're the same data, just represented differently. So this one we look at, if we're asking the question, how are they the same? Well, when we look at it, the information is still here. It's saying if we look right here, at July, it's still about that 375 mark in there, and so is this one at 375. They all have the same plot points, so we know that the information is the same on them. But when we look at it, it's obviously different because this graph here starts from 0 to 100 and goes up by 100. So we get the idea that, you know what, 375 was a pretty big deal here. They actually got a lot here. And on this graph, they're starting at 350, so it really doesn't look like they did a whole lot of growth in the first, from the beginning point here. But as we look at it, it sure looks like they climb, like skyrocket in here, because all of a sudden we look, it shoots up. But in reality, that's only going up 300 spots. And when we look at the accurate graph here, it's a bit, but not that much, because we've accurately done the numbers on the left-hand side. So we obviously know that the one on the left here gives that more accurate representation because it's honest all the way up. This one here, starting at 350, it makes it look like it was a small start, and then sales shot up, you know, almost to the entire graph size, like a large amount, which we know is not true. So pretty easy on that one. Let's look at some examples now. So in example 1, we look here at Matthew's test scores. So we can see that on test 1, Matt got 60. So let's just write this down first. Matt got 60 on test 1. He got what looks like 65 on test 2, 68 on test 3, and 69 on test 4. Now, these are not us. There are no B, M's, NY's, and EU's, so it's a little weird to do this. But let's take a look at the next part. From the graph, what appears to be true about Matthew's improvement? Well, when we look at it, he is improving. I mean, he's going up by 5, by 3, and then by 1. So he's made some improvements here, right? We know that. But what's distorted? Well, if we look at the graph right here, the same that we saw in the last question. Look on the side. It looks like here he had a tiny improvement from test 1, but from test 1 to test 2, look how huge the improvement is. It looks massive on this graph, but in reality, when we look at it, he only improved 5% and 3%. But on here, it looks like he's a genius now that he's gone up so much after one test. So let's look at what we could do to fix this problem. Here we look at Matthew's test scores again, and this gives a bit more of an accurate conclusion, right? We look at starting at 0%, well, it shows that he got 60 on his first test, and that jump to test 2 really wasn't as big as it showed on the misrepresented graph. It shows that yes, he did improve from test 1 to test 2 and test 2 to test 3, but they weren't sizable jumps. So I think we can see here that, again, by not starting at the right amount on the bottom at 0, we're able to misrepresent data. Let's look at another example. So in this graph here, there's a little bit different than we have in the other one. We've got two graphs trying to get the same information. They're showing, how many desktops versus laptops were sold. So in graph A, if we look at the question, how many more sales are there of desktops than laptops? Well, we know that the desktops sold 4,000. Oops. That looks like a 6, I'm sorry. That's a 0. And the laptops sold 2,000. So we know that they sold 2,000 more. But when we look at that graph B, how is it misleading? Well, the answer is pretty obvious. When we look at it, they've used way more spaces to make that laptop one. So if you just look at it in general, it looks like desktops crushed laptops. And yeah, there was that, 2,000 difference here to here, but by making it that much wider than this one, it looks to the human eye that desktops sold way, way more, which we know isn't true. But by just changing how wide the bar graph is, it changes what it looks like. So let's look at the next example. So here we're looking at a pictograph. So when we look at this graph itself, of the favorite pets of grade 8 students, which one looks to be the favorite? Well, if we were to look at this the way it is, we would say probably, fish would appear to be the most popular, because if we look, here's the end of the graph, fish are hitting the end first, so therefore it looks like fish is the most popular. But if we actually look at the information of each one, each picture represents 10. So in reality, cats are the favorite of 40, dogs have 40, but fish only have 30. So in reality, fish are not the favorite. It just appears to be that way because we drew the fish that big. From a picture, does it seem that more students like cats or dogs? Well, again, when we look at it, that dogs is right here, and it looks like there are more dogs than cats. The only difference, the dogs are much wider than the cats, because in reality, we know that they're both 40, right? It's 40 to 40. So they're actually tied, but it appears that way because the dog is farther out. So it would be dogs. How could we fix this graph? Well, I think the answer is kind of obvious here. We could all figure this out, that just making each thing the same size, right? Making sure that this fish, this dog, and this cat are the same size, or having equal spacing so that we know we can actually see the actual graph. So fish would actually be far less in this graph. So let's look at our final one here. So our final example is looking at a circle graph or a pie chart, as we've seen before. So if we were to look at this, it says the favorite ice cream. We've got chocolate 60%, vanilla 20%, and strawberry 20%. So when we look at it right away, it's obvious that chocolate is a huge favorite ice cream. But what's missing on the graph? Well, when we look at it, we don't know. We have no idea, right? That's supposed to be a question mark. There we go, big question mark. We don't know how many people were asked, right? If they only asked 5 people, well, that's not really a big indication of how many kids like chocolate, ice cream with vanilla or strawberry. That's not many at all out of 5. So if we knew the exact number, for each one of these, we would have a much better representation of this graph. But it's misleading because it says 60%, right? And that's kind of what we're looking at here is when we look at pie graphs, we need to know the numbers. Because, like I said, there's only 5 people surveyed and 3 picked chocolate, 1 vanilla, 1 strawberry. That's not really that big of a sample size. If we were talking about 100 people, right, well then all of a sudden this makes a lot more sense. That's 60 out of 120, 20. That seems much more valid. But by leaving the amount of people off it, that's really not that accurate. So again, that's another way to look at this. So on your assignment, there really wasn't much notes to take for this lesson. It's just more or less looking and seeing how can we misrepresent data to mislead our viewers, and how can we accurately portray them. So go ahead on the assignment in the textbook and then on the handout, and we'll go from there. So that's it for today.